Welcome to solverfy.
So for this problem, they are wanting us to use the balanced equation and the ideal gas law and van der Waals equations to find the pressure of O2 and H2, and they gave us knowns to help us solve this problem. So our first known is the volume, which is 20 liters. They tell us that the moles of H2O is equal to 28 moles, and they tell us that our temperature is equal to 23.8 degrees Celsius. I'm just going to add 273 Kelvin to this. So our temperature is going to be 296.8 Kelvin. I'm going to be using the R value 0.0821 liters atmosphere per mole Kelvin. And then we are looking for pressure of H2 and O2 in atmospheres. All right, so from the balanced equation, we know that if 28 moles of water is what we have, that requires 14 moles of O2. If we look at our balanced equation, for every mole of O2 we have, we come out with 2 moles of water. And then 28 moles of water requires 28 moles of hydrogen. If we look, 2 moles of hydrogen to 2 moles of water. All right, for the first part of this question, for part A, they want us to use the ideal gas law, so PV is equal to nRT. So we're looking for pressure, so P is equal to nRT over V. So we're looking for the pressure of O2. So that is going to be 14 moles times that by our R value, so 0.0821 liters atmosphere per mole Kelvin, times that by our temperature, which is 296.8 Kelvin, and we're just going to divide all of that by our volume, which is 20 liters. When we calculate this out, our pressure for O2 is going to be 17.06 atmospheres, and that is going to be our pressure for O2 using the ideal gas law. And then we're just going to do the exact same process for H2. Just change out the number of moles, so we're going to do 28 moles of hydrogen. We're going to times that by our gas constant, so 0.0821 liters atmosphere per mole Kelvin. Times that by our temperature again. And then just divide by our volume, which is 20 liters. So when we calculate this out, our pressure for H2 is going to be 34.1 atmosphere. So this is going to be our pressure for hydrogen using the ideal gas law. For part B of this question, they are wanting us to use van der Waals equation. So van der Waals equation is P plus n squared times constant A divided by volume squared times that by volume minus number of moles times B constant, and that's equal to nRT. So A and B are constants. This means that for every different gas that you deal with, it's going to have a certain A and B value. And so for H2 and O2, the A and B values are going to be different. So let's write down hydrogen's value. So hydrogen A value is 0.2453. The units for this is liters squared bar per mole squared. To get this into atmosphere, we're just going to times it by 0.986 atmosphere per bar. just to get it into units of atmosphere. So our A value is going to be 0.2419 liters squared atmosphere per mole squared. And then our B value for hydrogen is going to be 0.02651 liters per mole. All right, and then our O2 A value is going to be 1.382 liters squared bar per mole squared. Again, just going to times this by 0.8 or 986 atmosphere per bar, just to get it into units of atmosphere. So our A value is going to be 1.363 liters squared atmosphere per mole squared. And then our O2B value is going to be 0.03186 liters per mole. All right, so if we just rearrange van der Waals equation, we're going to get P is equal to nRT over V minus NB minus N squared A over V2. All right, so let's find the pressure for oxygen. So we're just going to take our number of moles, so 14 moles. We're going to times that by our R value, 0.0821. I'm just going to leave the units off just so that way I have enough room to write. And then times that by our temperature, which is 296.8 Kelvin. And then I'm just going to divide that by our 20 liters. And we're going to minus our 14 mole times our B value, which is 0.03186 liters per mole. And then we're going to minus 14 mole squared. Make sure that you square the mole, just so that way the units will cancel out. And we're going to times that by our A value, which is 1.382. And then we're going to divide that by 20 liters. Again, we're going to make sure that we square the liters, just so that way our units cancel out correctly. So when we calculate this out, our pressure for O2 using van der Waals equation is going to be 16.77 atmospheres. All right, and we're just going to do the exact same process for hydrogen. So we're going to have 28 moles times that by our R value. Again, just going to leave the units off just so that way I have enough room to write. And then we're going to times that by our temperature. And we're going to divide that by our volume minus our moles times the B value, which is 0.02651 liters per mole. And then we're going to minus 28 mole. Again, make sure we square that mole so that way it'll cancel out. We're going to times this by our A value, which is 0.2453. And we're going to divide that by our 20 liters. Again, make sure you square the liters so that way they cancel out correctly. So when we calculate this out, our pressure for H2 is going to be 34.89 atmospheres. Alright, so this is how we find the pressure for O2 and H2 using van der Waals equation. Part C of this problem is just wanting us to compare answers from Part A and Part B. So if we look, we see that the pressure for O2 is 16.77 atmospheres using van der Waals. If we go up here to our answer using the ideal gas law, we see that it is 17.06. So again, just a few decimal places off, but they're pretty similar. And then our ideal gas law value for hydrogen is 34.1 atmospheres. And then if we scroll down, we see that it's 34.8. So again, just a few decimal places off, but still pretty similar in precision in the answers that we got. So just when you use van der Waals equation, you're going to be using constants A and B that are particular to whatever gas you're working with. And the ideal gas law is universal for all gases, no matter what, because it doesn't need any constant. That is taken care of in our R value. All right, and that is how we solve this problem.